All right, today we're going to talk about a hidden quality that can literally make or break almost every piece of software you've ever used. It's not about the flashy new features or how fast it runs. It's something much more fundamental: maintainability.
So let's kick things off with a question that honestly sounds a little backward. Why on earth does software get more expensive after it's built? I mean, shouldn't the big cost be getting it out the door in the first place? Well, for most systems, the story really only begins at launch.
Yeah, and the reality is just staggering. For software that's meant to last a long time, maintenance costs can be anywhere from 2 to 100 times the initial development cost. No, that is not a typo. To put that in perspective, it's like buying a car for $30,000, but then spending up to $3 million over its lifetime just on upkeep and new mods. Understanding that huge number is the key to why we're talking about this today.
Okay, so to really unpack all of this, we're going to break it down into 4 key parts. We'll start with that hidden cost we just mentioned, then we'll define what maintainability actually is. After that, we'll explore it from 2 very different perspectives, and finally, we'll look at how we can actually build better software for the future.
Right, so that first point, the hidden cost. You see, the majority of a software budget in most big companies isn't actually spent on building shiny new things. It's poured into changing and evolving what's already there, keeping it valuable and relevant to the business.
Exactly. And that brings us right to the core concept. I mean, if most of the money is being spent on changing the software, then the quality we really need to be obsessed with is the one that makes those changes possible in the first place.
That's the word right there, evolve. Maintainability means software is built for change, right from day one. And you know, this is so critical because, let's face it, in any business, change is the only constant. Software isn't some static product you ship and forget. It's a living system that has to adapt or it just becomes useless.
So, what does maintenance even mean in this context? You might think it's all about fixing bugs, right? But look at this chart. It breaks it down perfectly. Only about 20% of that effort goes to fixing what's broken. Another 20% is for adapting to new environments, like a new operating system. But look at that huge slice. A whopping 60% of so-called maintenance is actually adding brand new features. Without good maintainability, that 60% becomes incredibly slow, super expensive, or maybe even impossible.
Okay, this next part is really the heart of it all. Because maintainability isn't just some techie behind-the-scenes thing, it has real-world consequences, and it looks completely different depending on whether you're the one building the software or the one using it.
Yeah, it creates these 2 totally different experiences. On one side, you've got the developer, who's swimming in things like code complexity and technical debt. But for the user, all of that translates into very real problems, like slow updates and bugs that just won't die. So let's start with the developer's world.
Right. From a developer's side, working with unmaintainable code, honestly, it's like trying to build a high-end Swiss watch in a completely trashed and disorganized workshop. Every single time you need a tool, you have to dig through piles of junk to find it. Parts are mislabeled, simple tasks become incredibly frustrating and take forever.
And in our world, that messiness shows up as what we call bad smells. Little warning signs that point to much deeper structural problems. For instance, duplicate code. That just means the same logic is copied and pasted all over the place. So if you need to make a change, you have to hunt down every single copy and hope you don't miss one. Or maybe you'll see long methods, a single piece of code trying to do 20 different things at once, making it impossible to understand. These smells make the code fragile and really risky to change.
Okay, Alex, hold on. That messy workshop is a great analogy, I get it, but you've got to translate that for me. What do these technical bad smells actually mean for me, the user, or for my business? How does that messy workshop affect the product I'm paying for?
Oh, it affects you directly. Believe me, that messy workshop means everything takes longer. That brand new feature you need to stay ahead of the competition? Yeah, it's delayed. That super annoying bug that keeps crashing your app? It's almost impossible to find and fix because the code is just a tangled mess. The system becomes rigid, costs go through the roof. And you know what happens? User satisfaction just plummets because the software can't keep up.
And when this neglect goes on for long enough, the software just degrades into what we call a legacy system. The structure gets so corrupted that every tiny change becomes this massive risky project. And at that point, the business is forced to make some really tough and really expensive decisions.
This table here really lays out those tough choices. Now, if the software is high quality, you're in a pretty good spot.
But take a look at that bottom row for low-quality, unmaintainable systems. If it has low business value, well, you just scrap it. But what if it's critical to your business? That's the real danger zone. Poor maintainability combined with high business value forces you into a brutal choice: a massively expensive re-engineering project or replacing the entire system from scratch.
So, the big question is, how do we avoid this whole crisis scenario? Well, that brings us to our final section. And the key thing to remember is that maintainability doesn't just happen by accident. It's the result of a deliberate, proactive approach to how you build software. Yeah, and a core practice for this is something called refactoring. This quote here sums it up perfectly. Think of refactoring as preventative maintenance for your code. It's like the continuous process of cleaning up that workshop we talked about, making sure it stays organized and efficient for the next job.
And the really crucial point here is that refactoring does not mean adding new features. It's purely about improving the health of the code you already have. It's all about making the software easier to understand, better structured, so that when it is time to add that next big feature, you can do it quickly and safely.
So what does this whole process actually look like in practice? Well, it's really a continuous cycle. Developers are constantly on the lookout for those bad smells Alex mentioned, and they refactor the code in small, regular steps. To do this safely, they lean heavily on automated tests to make sure that in cleaning things up, they didn't accidentally break something else. And really, underlying all of this is a shared commitment to keeping things clear and simple.
And that brings us to our key takeaway for today. The seemingly small internal habits of a development team, like continuously cleaning up the code, are directly, and I mean directly, linked to the external experience of the user. How software is built on the inside completely determines how well it performs and evolves on the outside. Right? So we'll leave you with this final question to think about. For any software you build or even just use every day, is it actually being built to last and to adapt, or is its own complexity designing it for an early and, let's be honest, a very expensive replacement?